Welcome to the video lecture for section R.7. This is for college algebra. My name is Jorge Gavillan. So in this section, these are the objectives that we're going to do. We're going to talk about rational expressions. We're going to multiply and divide rational expressions, add and subtract. We're going to use the least common multiple method and then simplify complex rational expressions. So the first one is reduce a rational expression to lowest terms. So here we have an example. We have x squared plus 4x plus 4 divided by x squared plus 3x plus 2. So just a quick review. A rational expression is just simply a fraction that contains a polynomial in numerator and the denominator. So when we are reducing these, the first thing we always want to try to do is try to factor the numerator and denominator. So here we can see that they factor to x plus 2, and then the denominator x plus 2, x plus 1. So we're able to cancel out an x plus 2 factor, and then we end up with x plus 2 divided by x plus 1. And this is defined as long as x is not equal to -2 and -1, because it's still restricted by the zeros of the original expression. The next one is multiply and divide rational expressions. So here's just a quick theorem. So a divided by b times c over d is equal to ac over bd, as long as b and d do not equal 0. So when we multiply fractions, we just do top, top, bottom, bottom. When we divide fractions, we actually multiply by the reciprocal of the denominator fraction. So a over b divided by c over d actually ends up being a over b times d over c, which then ends up being a d over bc, as long as b, c, and d do not equal 0. So how do we multiply and divide rational expressions? We have two examples here. We have a and b. So a is a multiplication problem, b is a division problem. And so leave your answer in factored form. So for a, you can see that we can factor out the first one, the fraction on the left, the rational expression on the left, factors out to x minus 1 squared over x times x squared plus 1. And then the one on the right factors out to 4 times x squared plus 1, and then x plus 2x minus 1. So we can cancel out an x minus 1. You can see that the squared becomes a linear term, then the x minus 1 in the denominator is canceled out. And then we can also cancel out x squared plus 1. And then we end up with 4 times x minus 1 over x times x plus 2. Leave it in factored form. And so therefore this is defined as long as x does not equal -2, 0, or 1, which any of these values will make the denominators in the original equal to 0. Now for example B, when we're dividing rational expressions, we're going to multiply by the reciprocal of the second fraction. So you see that we found the reciprocal there. And then we're going to go ahead and factor. So x squared minus 4 becomes x minus 2 times x plus 2. X cubed minus 8 becomes x minus 2 times x squared plus 2x plus 4. And then the x squared minus x minus 12 becomes the x minus 4 times x plus 3. So we can cancel out an x plus 3 term and x minus 2 term. And so we end up with x squared plus 2x plus 4 divided by x plus 2 times x minus 4. And then as long as x is not equal to -3, -2, 2, and 4. So the next one is add and subtract rational expressions. So the nice thing about this is basically the rules of fractions apply. So if we have a divided by b plus c divided by b, it just equals to a plus c over b. And then the same thing, if a over b minus c over b, what we end up with is a minus c over b. And of course, here's the other situation where we have a over b plus c over d. And of course, if we multiply by a factor, in this case a d, and then the second fraction by b to get the common denominator, then we end up with ad plus bc over bd, bd being the least common denominator or the new denominator. And the same thing if we're subtracting these rational expressions. So adding, subtracting rational expressions with unequal denominators. So we have x minus 3 over x plus 4 plus x over x minus 2. And then, of course, x cannot equal -4 or 2. And then for b, we have x squared over x squared minus 4 minus 1 over x. And then x cannot equal -2, 0, or 2. So for the first one, we are going to multiply the first one by x minus 2 and the second fraction by x plus 4. So if you go back to the rules that I just read, you can see that that's essentially what we did to find our common denominator. That's going to be x plus 4, x minus 2. And so we end up with x minus 3 times x minus 2 plus x plus 4 times x over x plus 4 times x minus 2. Now we can go ahead and multiply out the numerator, combine like terms, and then the final answer becomes 2x squared minus x plus 6 over x plus 4 times x minus 2. And then for example B, so what we're going to do is we're going to multiply the first fraction by x over x and the second fraction by x squared minus 4 over x squared minus 4. So you can see that our denominator is going to be x squared minus 4 times x. And then we can combine like terms in the numerator. And we end up with x cubed minus x squared plus 4. And then, of course, we end up with x minus 2 times x plus 2 times x. And what they did there was they factored out the x squared minus 4. And then now we're going to use the least common multiple method. So the LCM for adding and subtracting rational expressions, I'm not going to read this to you guys. You guys can go ahead and read that. But this is what we're going to use in order to add or subtract rational expressions. So here we're going to use the least common multiple to add rational expressions. So we have x over x squared plus 3x plus 2 plus 2x minus 3 over x squared minus 2. And again, the restrictions are that x cannot be negative 2, negative 1, and 1. So we're going to factor the polynomials in the denominator completely. So our least common multiple is going to be x plus 2, x plus 1, x minus 1. And so you can see that the first one has x plus 2, x plus 1. The second one has x minus 1, x plus 1. So in other words, what we have to add to the first one, so I'm talking about the x squared plus 3x plus 2, we just have to add or multiply x minus 1. And then for the x minus 1, x squared minus 1, the bottom one, we just have to go ahead and multiply x plus 2. So therefore, our new denominator becomes x plus 2, x plus 1, x minus 1. So they both have to have the same factors. And so you can see here that what we end up with is x times x minus 1 over x plus 2 times x plus 1 times x minus 1. And then, so in this one, we have 2x minus 3 over x squared minus 1. So we have 2x minus 3 over x squared plus 1. We factored out the x squared minus 1. So we're going to go ahead and multiply that by, x plus 2 over x plus 2. So you can see how we end up with the new fraction. And then the last step is we're going to go ahead and add these. And so step 4, you add them, and you can see the final step where you end up with 3 times x squared minus 2 over the denominator that we've had from the previous slide. So here we have another example. So we'll basically do the same thing, and this time we're going to subtract. So we're going to factor out the polynomials in the denominator completely. So the LCM becomes x times x plus 1 squared. Step 3, we're going to write each rational expression using the LCM as a denominator, so you can see what we do to each one. And then finally, we're going to go ahead and subtract them. So these steps are tedious, so you have to be careful as you complete these, because if you make one little mistake somewhere, your final step is going to be incorrect. And then the next thing we're going to do is simplify complex rational expressions. So the first option, we've got two options to doing this. In class, I will talk about perhaps a different way of doing it than the PowerPoints do. So here we have x squared over x minus 4 plus 2 divided by 2x minus 2 over x minus 1, and of course the restrictions 0, 2, and 4. So one of the first things that we need to do is we need to combine the numerator into one fraction and the denominator into one fraction. And so you can see what they did here in the second step. And then of course in the first line, in the third step here, you see how we end up with a complex fraction. So first step is we have to get one fraction in the numerator, one fraction in the denominator. This is this step here. We get to this point, and then how we divide fractions is we multiply by the reciprocal. And so before we do that, we do factor out the x squared plus 2x minus 8, which we did here. And then we turn around and we just multiply by the reciprocal. We can get rid of an x minus 2 term, and then we end up with x plus 4 times x divided by x minus 4. And so I'm not going to go through this example. We'll go ahead and do this in class. I think it'll be easier to explain rather than try to go through this step by step. So that's the end of, of review 7. Thank you.